Let's start with our first problem. So our first problem says the acceleration of an electron due to the mutual attraction between electron and proton when they are separated by 1.6 angstrom apart, okay, is, so we have to find the mutual attraction. Mutual attraction or repulsion means basically the force we have to find in this case, where we have one electron and proton and both are separated by 1.6 angstrom. So let me first write here electronic charge. One electronic charge is nothing but minus 1.6 into 10 raised to minus 19 coulombs, okay, and the charge of one proton will be equals to same 1.6 into 10 raised to minus 19 coulombs. And here the separation R is nothing but 1.6 angstrom. Angstrom is nothing but 10 to the power minus 10, okay. So this is our charges and separation. What we have to find? We have to find the force. So our force formula, okay, Coulomb's force is nothing but F is equals to K Q1 Q2 upon R square, okay. Be very careful, this is a magnitude over here, so we don't take the negative sign here, okay. So this will be simply, what is K? Let's substitute the values. K is nothing but 9 into 10 to the power 9. Charge Q1 is the charge of electron. The electronic charge is 1.6 into 10 raised to minus 19 over here, and into 1.6 into 10 raised to minus 19 for the proton, whole divided by the separation, which is 1.6 into 10 raised to minus 10 into 1.6 into 10 raised to minus 10, okay, because it's a square in the denominator, okay. So this is our force. Let's calculate it. So let me cancel the terms which are getting cancelled here. So this will be here 1.6 and 1.6, they will cancel out all of them. So let me cancel this 1.6 with 1.6 here, and we left with, let's see, 9 into 10 to the power 9, and in the powers 10 to the power minus 38 in the numerator, and denominator it is 10 to the power minus 20. Great, let's move ahead, okay. And here, which is equals to, let me take here, so which is equals to 9 into 10 to the power 9 and 10 to the power minus 38 and 10 to the power minus 20, that will become how much? 10 to the power minus 18, okay, 10 to the power minus 18 here we left with. So our result will be 9 into 10 to the power minus 9. Our result will be 9 into 10 to the power minus 9, and that's what force. So newtons. Let's read the question again. The question says the acceleration of the electron. We have to find the acceleration. So what we have calculated just now, we have calculated the force, right? So what is force by Newton's second law? By Newton's second law, let me write here Newton's second law from 11th standard. Newton's second law says force is nothing but mass times acceleration of the object, correct? So how much force we calculated here? Let me first figure out the acceleration. That will be in terms of force by mass, and that is 9 into 10 to the power minus 9 divided by the mass. How much is the mass over here? As per the question, if I scroll up, the question says mass of the electron is 9 into 10 to the power minus 31. So let's substitute here 9 into 10 to the power minus 31, okay, that's the mass of the electron over here. So this will be equals to 10 to the power minus 9 into 10 to the power plus 31, and 31 minus 9, that will give you nothing but 10 to the power 22. And what's the unit of acceleration? Meter per second square. Let's see if we have such an answer. So yes, option C is correct for question number 1.